Hello friends, in continuation with the last lecture, now we will talk about the thermocouples. Another principle used in it is nothing but the Thomson effect uh, with the other in combined with the other effect, that is Seebeck effect and the Peltier effect. So what is meant by the Thomson effect here, or the statement corresponding to it is that is the evolution or the absorption of the heat when the electric current passes through a circuit which is composed of a single material that has a temperature difference along its length. Means if there is a wire along with if there is a temperature difference across it, that is because of the electric current flowing through it. This transfer of the heat is superimposed on a common production of the heat associated with the electrical resistance to currents in the conductors. If suppose we consider a copper wire which is carrying a steady electric current is subjected to the external heat. If suppose it is subject to external heating at a short section, while the rest of the remaining is cool in the cool region, or the remains the cool, heat is absorbed from the copper as the conventional current approaches the hot point, and the heat is transferred to the copper just beyond the hot point. This, if you just suppose consider this is suppose a copper wire, and at some certain stage, if you just try to heat the object for the short period of the time, and the remaining other wire remains at the cooler region, then the heat is absorbed from the copper as a conventional current approaches the hot junction, and heat is transferred to the heat will be transferred to just beyond the hot point as well. So what are the different types of the thermocouples here? And there are various depending upon our requirement of the appliances. And there are various types, means whether we are requiring them in the some industrial purposes, or in some home appliances, or the some research purposes. There are various types. So the first type is the type S type of the thermocouple, which uses the pure platinum as one of the metal, and the other metal is alloy of the 90% of the platinum and the 10% of the rhodium as the other metal. So this is the alloy of the one of the metal, and then the pure platinum is the another metal used. So this type of the thermocouple are recommended for the high temperatures in the range from the 0 degree Celsius to 1400 degrees Celsius, and it must be protected with a non-metallic tube with a ceramic insulator. Another type, the second type is the type R, which uses the pure platinum as one of the metal and the alloy of the platinum rhodium. But here it is same as the type R, but the composition of the alloy, which contains the 87% of the platinum and 13% of the rhodium as the so that it becomes a varied its properties. So it is similar to the type S, but the type R is used for the industrial purposes, and the type S is generally used for the laboratory purposes. And now type J, which is made up of the alloy of the copper nickel metals. Okay, this is just one of the metal is the copper, and another one is the nickel one. So the temperature range is from the 0 degree Celsius to 1400 degrees Celsius, suitable for the vacuum or the inert atmosphere, because the copper will get, or the nickel, both them can getting just oxidized, so that mostly used for the vacuum or the inert atmospheres. At higher temperatures, the heavy gauge wire is recommended, as the iron oxidizes rapidly above the 550 degrees Celsius and reduces its lifetime. Type K, it uses the alloy of nickel chromium and the nickel aluminum. Okay, so type K, alloys of the nickel chromium and the nickel aluminum. The temperature range of this, again the 0 to 1400 degrees Celsius, and iron is not used as any metal. They are suitable for the continuous oxidizing atmosphere, mostly above 540 degrees Celsius. Then the next type is the type K, when it is exposed to the sulfur. This thermocouple might be subjected to the failure one. Between the temperature ranges from the 800 degrees to the 1000 degrees Celsius, just above the 1000 degrees Celsius, and at low oxygen concentrations, the preferential oxidation of the chromium causes the green rot, and large negative calibration drift occurs within this kind of the uh, thermocouples. To prevent such a scenario of this large negative calibration drift and the green rotting, actually ventilation or the sealing of the protection tubes can be used, or the can be done, sealing of that them. Now the next type is the type E, which uses actually nickel chromium and the copper nickel alloys as the thermocouples, and recommended for the continuous oxidizing atmospheres. The next type is the type E. They provide the highest thermoelectric output of all available thermocouples in the range of the 0 to 800 degree Celsius. Then the next type is the type T, which uses the copper as one of the metal, and the other as alloy of the copper nickel elements. Uh, these are the usable in a vacuum, oxidizing, and the inert atmospheres, and also works in sub-zero temperature. If we require the temperature below the 0 degree Celsius, then this type of the thermocouples are useful. That is up to the minus 200 degrees Celsius to 400 degrees Celsius, plus 400 degrees Celsius. We can use this type of the thermocouple. The other commonly used types are the type B, which is similar to type R and S but with a lower output, and the type N, which is used as suitable to K type, where it has a shorter life and stability issues. The next type is the type T. It uses, again in continuation with this it uses, type T uses the different combinations of the metals. They produce high output voltages at the different temperatures, and the output voltages curve is nearly linear and easy to interface with the controller one. Thermocouples are used in many industrial, scientific, and the original equipment manufacturers applications, or they are all also known as the OEM applications. Other industrial applications are the power generation, oil or gas, the pharmaceutical, biotechnologies or biotechs, the cement, paper and pulp, etc., etc. Every appliances are in, or everyday appliances are in the stoves, furnaces and the toasters one. Now, what are the advantages of these thermocouples? Let's see. Okay, low cost, high temperature limits, wide temperature ranges, durable to vibrations and shocks, small size, then rapid temperature responses. What are the disadvantages of this type of thermocouples? That is, I think the less suitable at high temperature, require extra protection from the corrosion, additional circuitry to control the application loads, because we need the external circuitry to measure the potential difference, the use of the spatial extension. And here it completes the theory part of the our chapter. Thank you.